What's up everyone, welcome back. Patrick here. Moving on to the next example. We have three expressions here and we have to evaluate them where x is equal to 2 and y is equal to 3. Now when you get a question like this, first thing you want to do is you want to take each expression and simplify it. Because plugging in an x value 2, a y value 3 at this point, it would be kind of hectic. There'd be a lot of calculator work and there's an increased risk of making a mistake. So what you want to do is you want to simplify it first, where there's not this much stuff going on, and then take your simplified expression, plug in that x value 2, that y value 3. So let's start with number 1. How would we simplify this? Well, first thing I'm going to do is I'm actually going to change these decimals to fractions. You don't have to, but I just like to work with fraction exponents versus decimal ones. So the 0.5, I'm going to change to 1 over 2. And then 0.2, what does that simplify to? That's like 20 over 100, which simplifies to 1 over 5. So 0.2 is the same as 1 over 5. And then from here, what I'm going to do is I'm going to take both of these exponents and then distribute them inside the bracket. So the 9, you know what, let's put the equal sign here. So the 9 is going to go to a power of a half. The x to the negative 6 is going to go to the power of a half. The y to the 4 will go to the power of a half. The 32 will go to the power of 1 over 5, right? All of these expressions are going to have an exponent 1 over 5. And then the x to the 20 is going to go to 1 over 5, and then the y to the negative 30. That will be 1 over 5 as well. Then from here, you just simplify. So 9 to the power of a half, that's like the square root of 9, which is 3. Negative 6 times a half, that gives us negative 3. 4 times a half, that gives us 2. The fifth root of 32 is 2. 20 times 1 over 5, that gives us 4. And then negative 30 times 1 over 5, that gives us what? Negative 6. Right, so took these and just simplified them. And then from here, you could simplify this even further. So 3 times 2 gives us 6. You want to look for exponents with the same base. So we got this x to the negative 3, x to the 4. Negative 3 plus 4, that gives us 1, positive 1. And then we have y squared times y negative 6. 2 plus negative 6 gives us negative 4. So this is like y negative 4. And we can make this even look nicer by bringing that negative 4 down. So this would be 6x over y to the power of positive 4. So that's what this simplifies to. And then at this point, you could plug in that x value 2, that y value of 3. So we would have 6 times 2 over 3 to the power of 4. So this would be 12. 3 to the power of 4 would be what? 81. And then 12 over 81, that simplifies further. You could divide both the numerator and the denominator by 3. So 12 divided by 3 is 4. 81 divided by 3 is 27. So 4 over 27 is the answer to number 1. You could actually potentially check this in your calculator. So you can actually plug in an x value 2, a y value 3 at this point, right? It's going to be a lot to plug in. Just be careful with all your brackets. You should get 4 over 27 or that same decimal. Moving on to number 2, wrote it up there. So we got negative 3x squared y negative 2 all to the power of negative 2. Then we got the third root of 8x to the 12 y to the negative 3. And then that whole expression is to the power of 2. So before dealing with this outside exponent, I'm going to simplify everything in the bracket. Multiple ways to do this. I could take this negative 2, I could distribute it in the bracket, this exponent negative 2. What I'm going to do first though, because this is negative, is I'm going to make a denominator. I'm going to bring that down, change it to positive, just because there is no denominator at this point. And then I'm going to take this third root and change it to a rational exponent, right? So I'm going to rewrite this here 8x 12y negative 3 to the power of 1 over 3. Right? Took that third root, changed it to an exponent of 1 over 3. This I'm going to bring down, so I'm going to have negative 3x to the 2, y to the negative 2. Everything in the bracket stays the same, it's just this exponent now is going to be positive 2. And then all of this is still going to be to the power of 2. And I'm going to simplify from here. So now I'm going to distribute both of these exponents. So this 1 over 3 gets distributed to everything inside the bracket. So 8 to the power 1 over 3. Then I'm going to have x to the 12 to the power of 1 over 3. Then I'm going to have y negative 3 to the power of 1 over 3. And this is going to be all over negative 3 squared, x to the power of 2 squared, y to the negative 2 squared. And then this here is going to be all to the power of 2. Now this 8 to the power of 1 over 3, that's going to be 2. This here would be x to the 4. This here would be y to the negative 1. All over negative 3 squared is 9. This would be x to the 4, and this would be y to the negative 4. And this is going to be all to the power of 2 still. Then from here, let's try to simplify. Notice that x to the power of 4s, they're both in the numerator and the denominator, so those can actually just cancel out. And then this y negative 1, this y negative 4, we could flip those. So let's continue this up here actually. So basically, I can write here, 2 over 9 doesn't simplify, so that's going to stay as is. Then this y to the negative 4 is going to come out, so that's going to be y to the power of positive 4. Then we're going to have a 9 here, and then this y to the negative 1 is going to come down, so that's going to be y to the power of positive 1. And this is still going to be squared. So y to the 4 over y to the 1, subtract the exponents, so that would end up being y to the 3. So we're going to end up with 2y over 9, and that's going to be squared. You can actually just plug in a y value of 3 at this point if you like, or you could even distribute the exponent to the numerator and the denominator. So let's just simplify this further. So this 2y is going to be squared, that whole expression. So 2y squared ends up being 4y squared, and then 9 squared ends up being 81. And now let's plug in that y value of 3. So 3 to the power of 2 is 9 times 4 is 36. So we'll end up with 36 over 81. And that is actually going to simplify to 4 over 9. Right? We could divide the numerator and the denominator by 9. So 4 over 9 is the answer to number 2. Simplified it first, and then plugged in that y value of 3 at this point. You could have also plugged it in here. So you'd have 2 times 3, which is 6. Then 6 over 9 is 2 over 3. 2 over 3 squared gives you 4 over 9. That may have actually been easier now that I said that. But either way, 4 over 9 is the answer you should get for number 2. So this is 4 over 9. And then finally, number 3 wrote up there. So we're going to follow the same process. Going to try to simplify it, then plug in that x value 2, that y value 3. So all of this here is being square rooted. So I'm going to change that to a rational exponent. So basically what's going to happen is that whole fraction is going to be to the power of what? It's going to be to the power of 1/2. So what I'm going to do is I'm going to simplify this fraction first, and then I'm going to distribute that 1/2 inside the bracket. So at this point, let's just distribute this exponent inside this bracket, this exponent inside this bracket. So we'll have 2 to the power of 4. We'll have x to the negative 2 to the power of 4. And we'll have y to the power of 3 to the power of 4. That's going to be all over 8 to the power of 2, x to the power of 2, and then y to the power of 2. And then that, all of this is still going to be the power of 1/2. Now, 2 to the power of 4, that's 16. Negative 2 times 4, that gives us negative 8. This would be y to the 12. and then simplify the denominator. So 8 to the power 2, that's 64. This would be x squared. This would be y squared. This is still going to be all to the power of 1 over 2. So let's actually continue this up here. So how can we simplify this? So 16 over 64, that simplifies to what? 1 over 4? 16 over 64? 16 is a quarter of 64. So that would be 1 over 4. The 1 we don't actually have to write unless there's nothing left in the numerator, and I think there will be. So this x to the negative 8, that comes down. That would change to x to the power positive 8, and then you have x squared times x to the 8, so that would give you x to the 10 in the denominator. And then you have 12y's up top, 2y's at the bottom, so you end up with 10y's up top. So you don't have to put that 1 there. And then that's still going to be all to the power of 1 over 2. And then I would just distribute that 1 over 2 at this point. So you'd have y to the power of 10 to the power of 1 over 2, all over 4 to the power of 1 over 2, and then x to the 10 to the power of 1 over 2. So that's going to simplify to what? 10 times 1 over 2 is 5, so this would be y to the 5. 4 to the power of a half is 2. 10 times 1 over 2 gives us 5 as well. Right? So this simplifies to that, and then at this point, you want to plug in that y value of 3. So 3 to the power of 5 over 2 times, and then that x value of 2, so 2 to the power of 5. And when you simplify that fraction, you end up getting 243 over 64. Right, so the answer to number 3 is 243 over 64. Now, one more comment that I want to make about this question is at this point, you could have also distributed that exponent on the outside. Could have made things a bit easier potentially. Usually I talk about how I like to deal with that outer exponent at the end. I like to simplify the bracket first, which is true for most cases. In this case though, I may have distributed that outer exponent early. So I could have took this to the power of a half and then this to the power of a half. Because 4 times a half gives us 2, so we'd just be left with this bracket to the power of 2. And then this bracket would be left to the power of positive 1, because 2 times a half gives us 1. But either way, you would get the exact same answer if you did it that way as well. But yeah, generally, I like to deal with that outer exponent last, first simplify the bracket. But sometimes I look for opportunities where I could distribute that early in the process, and then it may save me some time at the end. But yeah, anyway, either way, these are the 3 answers to these 3 expressions. So when you get a question like this, simplify the expression first, and then plug in your values.